Thank you for being here. The last batch of talks. I hope you guys had a great time at PuppetConf, just like I did. So I've been using Puppet for 5 years already, I guess a little more than that. My company is a Puppet Labs partner in Brazil. We mostly do consulting services and training services in Brazil. And on the region and remotely. So if you are interested in hiring someone to develop modules for you or anything related to Puppet, feel free to reach us. We are open to other opportunities in other countries too. I'm one of the co-founders of the Puppet Brazilian community. Basically, we just began a mailing list a few years ago, a website, and try to make people more aware of Puppet in Brazil. And also, I'm a very enthusiast about the DevOps culture and everything that brings us here today. So, how many of you have seen this error? I guess most of you. Actually, this might be, at the first glance, might be very annoying. It looks very annoying, like, oh, how can I have to do? Go to Puppet Master, clean the certificate, and generate a certificate again. But actually, that's the biggest proof that Puppet is working correctly, right? The master was not able to validate the certificate. So be glad to do that. Maybe you aren't being attacked, or there's a man-in-the-middle attack happening, and you might see this message or messages that looks like this one, right? So for those not familiar with what is a public key infrastructure, actually it's nothing new. I guess it's as old as DNS. And even DNS has like 30 years, and the basic concepts of a PKI date back for more than 20 years ago. It's still hard to do it right. So basically, it's a combination of storage and distribution of certificates. Certificates are what we know today, the best tool we have today to identify a public key, right? So this is the best we can do right now. Sometimes it's very clumsy to manage public certificates, so Puppet can help us a lot with that. And also, the PKI has this feature that we can revoke a certificate. So maybe an identity was compromised somehow, and then we need to revoke that and make that invalid. So if we find these features, in some sort of tool, then we have something that manages public infrastructure, right? One critical piece of the public infrastructure is the certificate authority, right? That's who or it who signs and verifies the identity of the public keys, basically. So there's a lot of responsibility on the certificate authority. Some of them might be familiar to us, like VeriSign, CertSign, these companies. And the CA is so critical. If the CA has any type of compromise, a security compromise, basically it's going to be, it's go bankrupt, right? They are out of business. It's something that cannot happen, never. So what is inside the certificate? Basically, we have a lot of information that can go inside it. The most important, some highlights here: serial number, the issuer name, the issuer name is who signed it, the certificate, who is the CA, for how long the certificate is valid, the subject name, which is usually in Puppet world we use the FKDN of the machine, right? The public key and which algorithm was used to generate and sign the public key, and a lot of more information. Puppet uses the standard X509 protocol, the format that makes this everything interchangeable and interoperable. Take a look at the Wikipedia page if you have some time later. This is a much more friendly view of a certificate from the point of view of Firefox, how the certificate can be seen. I took this screenshot from Puppet Labs website, and we can see there the common name, which is who the certificate is going to be issued to. Using in a Puppet word, that's the name of the machine, the name of the node, right? And then who signed the certificate, the key, the fingerprint, and everything else. So what is inside Puppet? How does it correlate to a regular public key infrastructure? Well, the Puppet Master can create, store, and distribute certificates, right? It does it all the time. You can find that out in this directory. In your Puppet, this is the path for Puppet 4. For Puppet 3 is /var lib puppet SSL, if I'm correct. Also, the Puppet Master can revoke a node certificate, right? Maybe if that node is decommissioned, it's removed and is not going to be useful anymore. One thing that we usually do is revoke the certificate. We usually use the command puppet cert clean. That command does two things. One is revoking the certificate first, then deleting it from the inventory of the CA. So, and also, when the agent connects to the Puppet Master, they validate and check each other's certificate. So the agent gives to the master its public key, its certificate signed by the CA. The master gives its certificate to the agent signed by the same CA, and they can check each other if they are valid. If that's okay, then we proceed to fetch our catalog and synchronize the plugins and facts and all of that. Sometimes understanding SSL is kind of challenging, and this is a picture that shows the workflow from 0 to when the agent is able to just send the report back to the master. So as you can see or not see, there are a lot of stuff happening until for us to get that final report of what happened with the node, right? Actually, we don't have to bother with all this stuff. We just are going to take a look closer to the beginning. This first part is where the agent has nothing. It's the first time it's running. It doesn't have a key, doesn't know where the CA is, doesn't have its certificate signed, it has nothing. This is the first time. Let's take a closer look. So I took this image from the Puppet's documentation. So you can find it on docs.puppelabs.com. I'm just reusing it. That's the idea, right? Don't redo stuff. So basically, if the agent is the first time, doesn't have its key, it creates one. Sometimes takes a lot of, sometimes some seconds to do that because it has to generate a random number for the private key. It checks if it has the certificate of the CA, the certificate authority. If it doesn't, goes to the server, to the Puppet Master server, downloads the certificate key, the CA key, and then from there, creates a new certificate. There's a special step that it's going to create what we call a CSR, a certificate signing request. So the agent creates the private key, creates the public key, creates a CSR, puts there more information on that, and then sends it to the master. At this time, when the master receives that CSR, it's when you can run the command puppet cert sign. While that doesn't happen, the agent does nothing. The agent is not able to download any catalog, any configuration whatsoever until you sign it, right? So at this point, we assume that you or the administrator has done, you have verified that the key that you are seeing is the correct one from the correct host, right? So you sign it, then the agent comes back, gets its certificate signed, and then begins the normal flow of downloading the catalog, apply configuration, send the report back, and all that stuff. So a little story about a consulting job that I've worked last year. Basically, I was working to deploy and automate some POS systems. They were basically computers that run a customized Linux distribution, and they were point of sales, right? This was done for a client in Brazil, for a retail fashion chain. So in every store, they had these POSs, these computers. They were going to change a lot of stuff there, and the new systems were thought in. The project was separated in two parts. One part was a team that was going to work at the installation process. So they had like an automatic installer, and this installer should detect the hardware, configure the hardware, install the basic operating system. And then the other team where I was working for, we should handle Puppet. So after the basic operating system was installed, Puppet took over, and Puppet does the heavy lifting of installing all the rest of the software and configuration needed to get the POS working. So the first scenario that when I was there was, this is the size of the project. We had like 5,000 point of sales computers around distributed over 200 stores in Brazil. The installation team was supposed to get the Puppet agent package, leave it, make it pre-install it on the image, and then pre-configure it, right? So when the computer boots for the first time, the POS boots the first time, the Puppet agent is already configured and points to the correct Puppet master. And then the Puppet master was going to be hosted at the offices, at the HQ. That's what they call. So this is a basic drawing. That red box that says Puppet Master, it's a very simplified image because we have much more complexity around it to handle 5,000 nodes. So let's just simplify a little bit and imagine that just one master, right? This is the basic. We are very used to this type of design. No big news for us today, right? So someone from the technical team that were more experienced people working on retail. I don't know how many of you have worked on retail business side, and retail is very challenging. We don't have like the comfort of being in a cloud usually. So you have stuff spread around the country geographically, and a lot of strange things happen, like routers go down for no reason. Connectivity is a real issue. So people asked, what happens if the link on the store goes down? What happens after that? Well, while the link is down, we can get no reports from the POSs, and we cannot distribute new configuration. But the operation still works without any problem. But someone asked us, well, just in case we need to replace a POS while the link to the HQ is down, would that be possible? Actually, no. We need to reach for the Puppet Master to do something. When the Puppet agent runs for the first time and the master is unreachable, there is nothing it can do. So this is the first change that we had to do to accommodate these requests. So we came for a second scenario. We have one Puppet Master for each store locally. Then when you begin designing using Puppet with multiple Puppet Masters, the first challenge is the Puppet CA, because the Puppet CA basically is a private key, and it's not a good idea to copy this key over 200 machines, 200 Puppet Masters having the same key. And we were not able to have 200 local Puppet Masters with 200 different CAs, because that will cause a lot of trouble for us because we got all the reports to PuppetDB, and PuppetDB also uses SSL, also uses Puppet certificates. I'll talk about that more later. And so it doesn't look good. It might be very challenging, and that's not a good idea. This design of taking one Puppet Master, especially just to be for the certificate authority, that's the recommended way. And that one stays at the HQ. So the local master will have a copy of everything it needed to configure each agent, each POS, and very good to go, right? We don't have any connectivity. To do that, we need some small changes of configuration. One, the first box is on the local master. The local master is not going to be a CA anymore. It doesn't answer for CA requests, for certificate requests of any kind. So we need to set CA to false. On Puppet.conf, on the POSs, on the nodes, we need to add the CA server option. Then the POS has two masters that it talks. One that's CA server, just to do the first step to get the certificate, and the rest for the configuration. After we have our certificate, we don't talk anymore with the CA. So this is a simplifying view of what we're doing here. The POS, when it wants configuration, goes to the local Puppet Master at the store. When it needs requests, so if there are new POS being replaced, and that happens all the time when you have like 5,000 devices, every day they're going to be replaced, at least 3 or 10 of them. That's the statistics they showed me. So that red box, the Puppet Master CA, doesn't have any configuration. Actually, there are some gotchas here. How can we still didn't solve the problem of having being able to deploy a new POS without connectivity, right? We still need to talk to the Puppet CA to get our certificate. If we don't have any certificate, the agent is not going to do anything. Well, how can we get away with that? So we had this idea. How about inside the installer image, there was just a flash drive image, we put it on the POS, it boots and install the Linux system. We put a pre-signed certificate just for that occasion. Someone from field services go to the store, needs to replace a device, needs to reinstall everything on that new POS, the link is down. We just need that moment, because that's the biggest cost in retail, when you need send someone on the field to do something. They hate to do that. So you cannot waste the time of the guys from the field services. So we did some tricks when bringing up the network interface. We check if we can reach the Puppet CA. If we can find the Puppet CA, then we change Puppet's configuration a little bit, and Puppet agent starts using a pre-signed certificate. When the connection to the CA is back, we delete the pre-signed certificate. We are not going to use it anymore. Then we talk to the CA and get a proper certificate. So this is what's happening. When the connectivity is down, then the black box over here say configuration plus pre-signed certificate. So the POS boots in a special state, considering Puppet's configuration, to just use that pre-signed certificate. Uses a generic name. That certificate is signed by the same CA. The local Puppet Master has a key signed by the same CA, and everything locally works. We can deploy a new POS without connectivity at all. So we face some problems still. First one, people asked, well, did you say that the POS is going to directly connect to a machine at the HQ? I said, yes. The POS needs to talk with the CA. So someone later on the process come up with this very sad information that we could do that. We can't do that. They had some policy there that the network of where the POSs were, they were isolated and they cannot open a connection to the HQ. We had to figure something out. So how can you solve this? So scenario three. Here's the problem. We need a CA, but we can't talk to the CA. There is this network. The firewall, I guess, was easier for me to try to figure something out than fight the people from the security team, right? So my idea was, at the time we were using Puppet 3, so we were using Puppet with Apache and Mod Passenger, right? So my idea was, and this is very common too, we configure Apache as a reverse proxy, but just for the CA protocol, just for the CA URLs. And then we remove the CA server option from the POS. The POS will think that he's going to talk directly with the appropriate CA server. This is the trick. This is a small snippet of a configuration of Apache. Then what happens here, these 2 lines are responsible for this, how we solve that. When the agent, the Puppet protocol is very straightforward. It's just HTTP, right? There's no secret there. So this beautiful regular expression, when we see a certificate, the word certificate in the request, we forward that to the actual Puppet CA. So the connection goes from the local Puppet master, not from the POS. The POS connects to the local Puppet master, the Puppet master, the Apache one. When the requests are certificate related, it intercepts and sends back to the original Puppet CA, so we didn't have to fight the firewall people. That's what's happening. So we have the local Puppet master. The POS is not going to talk anymore with it, just for configuration and the CA requests. But just the CA requests go through the HQ, but they go through the local Puppet master. And with this design, the problem of having the link down and still being able to deploy a new POS while we don't have this connectivity to the CA, it doesn't matter because we are using the pre-signed certificate. So no change there. The POS, while the link to HQ is down, so we boot with a pre-signed certificate and nothing changes, right? People are very happy about it. Finally, I guess. Then I didn't have to change everything I was working. Then I was having a casual lunch with some of the guys of the installation team. I usually didn't talk to them that much. But one of them was more friendly to me, and I was closer to him. And they seemed very worried about something. And then I saw people on the other table arguing and waving hands and saying, what's going on? So this is what they said to me. So every POS on every store connects to the network using Wi-Fi. Why is that? Because that is a fashion retail store. So it's fashion, right? Cables are a barrier to them. Usually they want to change the layouts of the store where the POS are going to stay very frequently. So cables are no option. That's someone has decided to use Wi-Fi. The problem is that every single POS uses the same password to join the Wi-Fi network on every store in the entire country. So if you have worked on retail, at the time, this was my first time dealing with retail people. Unfortunately, that's not very uncommon, this crazy stuff. The target hacking here in the US, where hundreds of millions of credentials and credit cards were stolen, or something like that. I guess the attacker got a password, a username and password from the HVAC system, for the air conditioning, and then from the local network, he was able to compromise a lot of stores, right? So retail is tough. Don't blame them. Not yet. There was this PCI DSS committee. PCI, for those not familiar with, is a payment card industry data security standard. This is a security standard where if your business deals with credit cards, you need to comply with this. So they were saying that they were on their neck and they had to solve it. That they were like turning their faces and ignoring that there was a problem there. But they were running out of time and they had to figure something. And the PCI DSS people requires that they uses 802.1x for authentication. Not just 802.1x, with TLS. So that involves using certificates to do proper authentication, right? So, and then the guy said to me, we have no clue how to make certificates. We have no idea how we are going to distribute them. We have no idea how we are going to sign and revoke and put each one on the POSs. And then they asked me, do you know something that manages certificates? I said, well, that's your lucky day. I guess I have something to do. Then I asked him, explain to me what's happening. I'm not a networking guy. I have a little experience with network equipment, but I can get the picture of how that works. So this is a very simplified drawing of what's going on here. Each POS connects to the local access point on each store, sends the password, the PSK, the pre-shared key to the WLAN controller. The WLAN controller stays at the HQ. WLAN controller forwards the request for authentication to Cisco ISE. I'll talk more about that. Cisco ISE then replies with which VLAN or if that machine is authorized or not to be in the network. The WLAN controller puts gets authorization and reply to the access point. You can allow this device or not. So the Wi-Fi was was using Cisco Identity Services Engine, right? This is the tool that manages the identification and authorization and validation of our network. It's basically radios, right? Nothing, just a fancy name for doing radios. So my idea that I had at the time when he was explaining to me, I said, man, I guess if you get the Puppet Master CA, the public key, if we can put it into ISIS certificate store and then make ISIS understand that that's a valid root CA, that might work. We can change the configuration of WPA supplicant to use the Puppet certificates, the same certificate that I use for the agent. It's going to validate that, see that certificate comes from an unknown authority because we put the CA key into Cisco ISIS. That should work. That might work in theory, right? So after this time, I need to renegotiate my contract because I guess I was helping them a little too much. So the new design here is this. The POS, instead of sending the PS key, the pre-shared key, sends the Puppet agent certificate. Same thing. Sends the WLAN controller talks to Cisco ISE. Cisco ISE then has the public master CA inside it, sees that that's a valid certificate, replies to the WLAN controller, and the authorization is released, right? In theory, that should work. Actually, it did. People were crying. We solved the problem, sort of. Another challenges came up after that. One of them is that the POS needs to join the network and then request its certificate, right? If we need the certificate to join the network, how are we going to get our certificate? For those more experienced with Puppet, we call this dependency cycles problem, right? So how can I join the certificate? How can I join the network using a certificate if I can't be at the network to talk to the master CA to get my certificate? How can we solve that? After some back and forth, I come up with this design. Let's keep the PSK just for a little bit, so we can put it in the installer image. That's hard-coded over there. That's not. Let's reduce the criticality of the information, right? So when we join the network using the PS key, the pre-shared key. But we do a special configuration between Cisco ISE and the WLAN controller to put the POS on a restricted VLAN, a VLAN that only can talk with the local Puppet master on port 8140, sorry. So we have all the network we need to get our certificate, nothing else. Then we do that initial dance to get the certificate, talk to the CA, and blah, blah, blah. We disconnect, connect again, then using the certificate. Now, everything works pretty fine. So this design was approved, and a lot of people, especially from the PCI DSS committee, they approve it. And we were very happy. Now they have a decent security, and Puppet is helping them manage the certificates. So some lessons here. The agent certificate's there. Why not reuse it, right? All these tasks that a public key infrastructure does, and the certificate authority does, store, manages, signs, and revoke, and clean the certificates, Puppet masters already do that. Just a warning. Be careful. to understand the implications and the risks of reusing the same certificate for different purposes, right? But, and especially, the Puppet CA also, we have a CRL. It's a certificate revocation list. So each time you run Puppet cert clean or Puppet cert revoke, a special file inside the directory of the CA called crl.pm, it's changed, it changes. We use that file and put that on Cisco ISE2. Actually, you are already doing that, if you didn't realize. Many components of a Puppet ecosystem talk to each other using SSL, right? And for instance, when the Puppet master or server sends data to PuppetDB, that connection is protected using SSL, and PuppetDB certificates are the same certificates used by the agent. We don't have to create another pair of those. mCollective, same thing. Talk with ActiveMQ, where Puppet Enterprise uses the same certificate of the agent, Puppet agent, to talk to ActiveMQ. The classification services from Puppet Enterprise, there is a certificate for that too, and it's stored in Puppet CA. The web console, same thing. We are doing it. PuppetDB, there is this special command called SSL setup, right? What it does, just makes a copy of the agent private and public key, put them in place in /etc/PuppetLabs/PuppetDB/SSL, and everything works just fine. mCollective, same thing. When we talked with ActiveMQ, we reuse the Puppet agent certificate. It's the same file. You can check it out. It's the same file. The Puppet modules from Puppet Enterprise just makes a copy. Some tricks with the Puppet CA certificate. Unfortunately, or fortunately, I really don't know if this is by design or not, the Puppet agent does not read certificate store from the operating system. It's completely separate. It doesn't have any access to that. It's not used at all. The Puppet CA is also, that key is not included in the operating system certificate store. It's not there. It's just on the disk, only Puppet uses, but the operating system is not aware of it. There's some cool stuff that we can do. There is these two modules, one from the Puppet community for Windows called SSL certificate, and this one from EvenUp called Trusted CA. With those modules, we can get any type of key or certificate key from a root certificate and import them into our operating system. So this is on Windows. This is the manifest. Using that module SSL certificate, we can store in Puppet CA key in Windows. This is the trick with OpenSSL. We need that number here, this hash, the fingerprint. This is the Windows API requires that. That's why it's there. And it works. You can see it there in Puppet, in Windows Certificate Store. You can see the CA as a trusted root. And doing this, we can gather read a lot of those self-signed messages or authority not recognized when we are managing our Puppet infrastructure. For example, when we access the Puppet console, the Puppet Enterprise console, this is a screenshot from Puppet Internet Explorer, or Chrome, that will work too. We don't get any warnings anymore. Very smooth. There's a CA. This one is for Linux machines. The same thing. We just pointed the source to the Puppet CA certificate file that the agent downloads for the Puppet Master CA. It's going to put it in the certificate store on Red Hat systems /ATC, /etc, /PKI, somewhere down the directory. Some issues that we need some extra security too. When we can use the Puppet certificate for that. Actually, in Puppet, facts might be a lie. A fact might not be a fact. Facts can be spoofed. So if a node is compromised, it's very easy to tricky factor to generate wrong data. You don't even have, let me show you. The danger is sometimes people use data from factor to decide if this machine has, the node receives critical information like credentials, passwords, API keys, something like that. Take a look at this Hira configuration example. We are checking for the hostname.yaml file, so any specific configuration for the hostname, right? But that information can be spoofed. If I compromise a node, I can just run that. So maybe I want some special credentials from another machine, right? I can, the first command, factor hostname, node 1. I can create an external fact, which is just a simple text file. And then when I run factor hostname, factor is going to read from the text file and will not use the one that's detected by the core factor, right? So when we go back here, I am going on the Puppet master, I'm going to receive configuration that was not supposed to be mine. I can change the hostname. How can you solve that? Trusted facts. Some facts we can trust. There is a special variable, actually a hash in Puppet code called the trusted. So everything inside this trusted hash comes from data inside the certificate. So that's unspoofable, as far as I know. Maybe NSA knows some way how to do that. But as far as a regular man here, I don't know how to do that. So this is the example of the hash, of the trusted hash. So it's much better. You can use this variable in Hira. This is much better. Instead of using the hostname, you can use trusted.certname. Certname is one of the keys of the hash, and it's much more reliable, right? You can put your information yourself there. Puppet has this special case. Usually people don't use that. This is a very corner case, but it's there. When the agent runs for the first time and it creates the CSR, the certificate signing request, after it's signed, you are done. We are going to face the first error. If we delete the certificate from the master, you cannot recover from that. So it's sealed. How about we get some extra information to use on that trusted hash? This is how we do it. There is a special file called CSR attributes.yaml. It stays on the Puppet configuration directory. This is how it looks. You can put some attributes there. I don't know how many of you have used SNMP and used OID. This is the same thing. Puppet Labs has registered some OIDs for its namespace, and we have some names for this OID reserved for Puppet Labs. This is two examples. There is this extension called pp cost center, pp environment, where you can put anything on this file. So when the agent creates the certificate, this certificate signing request, and when the master signs it, this information persists into the certificate. So it will be available as a trust variable. So you can use it whatever you want. There are, I guess, 15 or more extensions to that. A little heads up about the cert name. Cert name is the configuration option we use on puppet.conf to create the common name that goes into the certificate. We use that to do everything. Like when we see the node on the console, that's the cert name, right? We face some challenges on a client of ours and that name must be unique. The CA will not sign different certificates for the same cert name, for the same common name. They need to be unique for each CA. That should be enough for most use cases, but we had a client that they have a disaster recovery site, and they have everything mirrored there, including the names, DNS, everything. And we want the same Puppet master to manage all of that. And there were collision names because the same machines had the same name. You need to do some tricks to solve that. One last trick, you can change the name of the authority to something more friendly. This is this OpenSSL command here. We show the content of the certificate. The red boxes are the name used and generated automatically by Puppet. They are not beautiful. They are not maybe easy on the eye. We can change that. Usually, we say, why am I going to do this? Deal with a bank or a financial institution. You will begin to see people asking this type of question. So how we do that? There is this option called CA name in puppet.conf. You can put it whatever you want, your company name. A heads up about the Puppet server. There is a bug right now, bug 528, where when you start Puppet server for the first time and the CA key is not there, but the Puppet agent has already run some very nice track trace exception will show up in the logs. To solve that, you manually run Puppet start list. Puppet start command, if the CA key is not found, it creates one, then takes the name that we have changed. This must be done at the beginning of the project. If you are like, you already have like hundreds of nodes configured by Puppet, and you want to change the CA name, that's like a brain surgery. That would be really tough. Then that's it. You can change the name, make it more friendly, easy in the eye. Maybe if you are importing the certificate into an operating system certificate store, like we did on Windows or Linux, much better, right? So, questions? I guess I'm almost out of time. The mic is going to go there.
Do you know, is there a way you can make your Puppet CA subordinate to like an upstream CA? So like you'd be able to have your Puppet CA cert signed by an upstream CA?
Yes. The Puppet server supports external CAs, so you can turn it off everything here and import an external CA and use that CA to sign the certificates for you. There are some tricks on the Puppet agent because the Puppet agent can't validate a certificate chain. So if you have like more than one level of validation, the agent will not be able to validate that. So it depends, but you can bring your own keys to the party. Thank you very much. Hope you guys next year.